Easy adjustment there.
I take that back.
I take that back.
Somebody's
Somebody's changed this to 90.
This one happens to run
This
at
one
80.
happens to run at 80. No problem.
Okay.
Okay?
Pressure gauge.
Pressure gauge.
Simple gauge.
Simple gauge. Reads in PSI. That's what they're expecting to look at. It must be installed on both sides of the regulator, high pressure and low pressure.
And I'll get into that.
And I'll get into that in a second.
Okay, the pressure
Okay,
regulator.
the pressure regulator,
Which is
how
this system right
how
here
this
runs.
system right
is
here
you're
runs
running
is you're
your
running
high pressure
your high pressure system here, which is 120 PSI,
running to the reservoir,
coming down, and it's going to the first regulator.
You're allowed to run
You're allowed to run 120 PSI on the high side pressure reserve pressure.
But all of your
But
actuators,
all of your actuators
and all your devices
can only run at 60 PSI.
So you have to
So
run
you
a
have to run a
regulator
regulator
to drop that down to 60
to 60 PSI. So they have to be have two gauges minimum, one for the high pressure, one for the working pressure.
Now, you
Now,
don't have to run things at 60,
at 60,
but you can run a
a
maximum
maximum of 60.
Okay, it has to be
Okay, it
self-relieving.
has to be self-relieving.
Okay? Now what that means is if there's an overpressurization, like you have a cylinder and it gets compressed by some other device or a robot interaction and it raises that pressure above 60, that regulator has to be able to relieve itself. Okay? Accumulators or air tanks. They come in different configurations, okay? The plastic ones are the lightest, they're the easiest to use, they have push fittings, but there's also stainless steel ones, which are substantially safer, okay, but they're heavy, so there's a disadvantage there. They also have threaded fittings, so you have to use additional elbows and connectors. Okay? Now, these things have 120 PSI, and when I said earlier that you can't modify a factory component in any way, one of the reasons why, if you get a scratch on this, a deep scratch, or you damage it, they could catastrophically blow up. So, the video will play. This is a 120. There you go. Now, if you can imagine that happening during a competition, and then it goes out in the stands or across and hit somebody, that is why they are so particular about not modifying factory components. If you have a damaged or a malfunctioning reservoir, and it is one that is listed in the manual as being able to be used, they will replace it for you free at the competition, because they don't want one to blow up, okay? So whenever we have a bad one, that's what we do. We say the bad ones, and we go walk up there and say, hey, we have a bad one, and we get a new one. All right. These are the air cylinders, okay? These are come in many shapes, many sizes, fat, short, pancake. This is a very long cylinder here, okay? Down below is a pancake cylinder. It's really, really short for just short actions, tight configurations. And again, you can't modify these in any way. You can't machine on them. You can't drill on them. You can't add things. You can't weld to them, anything. It has to be as it came. Okay, this is just kind of some simple calculations of air cylinders. The big thing that is trying to push is you have maximum 60 PSI, that's 60 pounds per square inch, okay? You have a cross section of your piston, okay, that's in square inches. You multiply the two together, you get the force that the cylinder can do, okay? One of the things that you have to realize is a cylinder will have more power pushing than it will pulling, okay? And the reason for that is when it's pushing, you have a piston inside there, and you get full pressure against the back of that piston, okay? But for it to pull back, you have a piston, but you have a rod coming out the end of the cylinder. That removes part of the cross-section that the air is pushing on. So it will always push harder than it pulls. Does that make sense? Okay. So if your intentions is what you need to do is push more than you need to pull, you need to make sure that The action you do is in a pushing action. One to see on this robot right here. It's more important for this robot to push this way, so it pushes out to grab the cube rather than pull back out like that. By the way, if you can hear listen real quietly, okay, right now this is at 60 psi, but when I put more pressure and it actually compresses it, listen to the regulator self-relieve. Okay, that's not allowing any more than 60 psi to be in that cylinder. That's the kind of regulator you have to have. If you're buying your own regulators, you can get them from Andy Mark, which are a great big one, or you can buy a little small ones from Automation Direct, which is what on this robot, and you can come see later, or what's up on this board. You want to point to a regulator? Okay, they're all self-relieving, okay? If you are tight on space, which we always are, that's why we use these small Automation Direct ones. If you use what comes in your kit of parts, it's a much bigger one. They both function exactly the same. Any questions on calculations of cylinders? And we'll go into that more later. Okay, this is again the same thing, explaining on the pressure, and this will be available on the website, this whole presentation, so you can go back and look at it. I know we're going through some of this stuff pretty quick. But this is how to calculate what force you need so you can buy the cylinders. There is a voucher in your virtual kit for Bimba where you can get 2 free cylinders, okay? Cylinders are anywhere from $25 to $35 a piece, and it's very good to get them from Bimba for free, but it takes 2 to 3 weeks to get them, so as soon as you figure out what you need to do, you need to order them. Okay, here's all the different kinds of fittings that you can use. The ones on the to my right are push type fittings for the airlines. These other ones are your hard fittings, your brass fittings.
Is there anything wrong with aluminum?
No, not at all. Not at all. Okay, Teflon tape. If you're using brass fittings or threaded fittings, you have to seal them, okay? There is a proper way to do it and an improper way. The one you see on the what's wrong with that is the Teflon tape is wrapped over the edge. The problem with that is that when you screw that in, it leaves a little tail of Teflon that can get into the system. These solenoids are extremely touchy about particulate or contamination. That little thing will make that thing, the solenoid, not function properly. Solenoids are anywhere from $70 to $100 a piece. You don't want to screw them up. And they can be taken apart, they can be serviced, but I guarantee you there's a lot of pieces inside of them.
Question out there.
Yes?
The slide for the Teflon tape.
Yep.
Yeah, what's the left picture?
Okay, those are the different kinds of fittings. You have brass fittings that are threaded fittings for elbows, connectors, and some of them have push fittings, all of those. The other ones are the different ways you can connect your airlines. So you'll see various fittings here, different ways of connecting the airlines. That's what those are. Okay, they're a push to connect. I'm going to get in and explain airlines in a little bit, but yeah. We recommend the push to connect, okay, because they're just so simple and easy to put around. Okay, airlines, you have to use a 1/4-inch airline, okay, maximum ID of 0.160. What that is that's so you only have so much flow so fast. It has to be rated for 120 psi. Every airline has got the writing right on it. Your inspector will be looking for that to make sure you're using the right airline. You can use nylon, you can use polypropylene, as long as it's rated for 125 psi. We use 200 psi line. And color doesn't matter. There's clear, there's light blue, dark blue, red, doesn't matter. Okay, when I said that the valves were complicated, there's a cross-section of one of the solenoid valves. There's a lot of pieces in it. They're piloted, there's a lot of check valves, a lot of seals. You don't want contamination in it, you don't want dirt in it, you don't want to drop them in the dirt, okay? They're difficult to clean out. And like I said, they're anywhere from $70 to $100. A single acting solenoid, which is like the one you see one set of wires coming out of, okay, those are about $70. The double acting solenoid with wires is $100. Electrical. It's pretty easy to wire one of these up. And this is, all the systems that go to the electrical is on this board right here. You have a compressor, you have a pressure switch, which gets wired to the pneumatic module, which is the black box right there. That's $80. You have a set of solenoids, or a solenoid. That is all the electrical that it takes to run the entire pneumatic system. Any questions on that? Yep.
So do you need to buy one solenoid for every cylinder that you buy, or can you use one solenoid for multiple?
Okay, you could use one solenoid for multiple cylinders if they're all doing the same action, okay? But you can only use, you can't run one cylinder with two separate solenoids, okay? Because they want to be able to control what's going to happen to that cylinder and track where that comes from.
Alright.
And if you had two solenoids, they could fight each other, they could act unpredictably. But like this one right here, both of these cylinders right here are activated by the same solenoid. That's one of these back here.
Okay, thanks for clearing that up.
Sure.
There's been a lot of talk about two speeds. You can't do, they don't allow two cylinders, two solenoids on one valve.
They do not yet. That's correct. Yes,
Can you run any solenoids without the PCM? Like, is there any way?
absolutely not.
No.
You cannot. All the control to any electrical pneumatic solenoid has to be done through a PCM. And the reason why that is the compressor's controlled through that, through your Roborio, through your program. Any other questions on that? Okay. All right, to wire it up, exactly, you have to run power to your pneumatic module, all right? And you have to run the pressure switch, also goes in the pneumatic. It's clearly marked right on the pneumatic module where those wires go. One thing on wiring that we recommend is to use ferrules on your wiring. Are you guys familiar with what wiring ferrules are? Okay, what there is there's a metal collar with a plastic sleeve, and you place it over your wire and crimp it with a special tool. We didn't bring one. But what it does is it eliminates the potential for wire whiskers, which are the little strands hanging out. Some of these connections are so tight that if they cross, of course, you either get a short or they won't work, or they work unpredictably, or the wires fall out. And so anyway, you can come up and see those when you're up here. You look, and if you want to go over and look at our robot, there are large ones for the big power, there's little ones for the pneumatic module. Okay, safety and controls, again, we talked about those a little bit. You have your compressor, you have the switch, you have the pop-off, and the gauge, and the dump valve. Like I said, they recommend that this stuff all be hard piped with brass fittings to the compressor.
Do you ever have, because that's considerably weight or heavy,
Yes,
do you ever break the compressor with the vibration or the
We never
impact
have.
of the robot?
we never have. And we've had some pretty serious abuse, and we've actually dropped this robot climbing, what, 4 times now? So, okay, how to get through your robot inspection. Okay, like I said, when it comes to getting your inspection, they will go over pneumatics more than any other part of it, and it's strictly for the safety part of it. You need to want to make sure that all your working and storage pressures are within the limits. 120 PSI on the high side, maximum 60 PSI on the working side. Now, you'll find out that 60 is too much sometimes, okay? So we've got more regulators downstream of that drop it down from 60 down to 20, down to 30. Okay? Calibrate your pressure relief valve. You need to do that ahead of time, but they're going to test it to make sure it works, and they do every time. Okay? Make a pneumatics diagram. This will really help, because they will then, the robot inspector will know that you understand your system. And the other thing you do want to do is you do not want to make spaghetti works, so they have to try to follow and figure it out, okay? You want to put your lines as clean as you can. If you look down here, you can kind of see the flow of things that we did for the regulator and show it out. But one of the main things you're going to see is that this gauge is on the high pressure side, that gauge is on the low pressure side.
Question?
Yep. and 60 in another, you do not. As long as you're down to 60 on the working part of it, that's the only time you have to actually have a gauge. But for you, it's nice to have that extra gauge, but that's why we use the really small inline ones, so we can put them on, so we know where that line is at and what it's really doing. But you can do it by trial and error and find out what you want it to be, because as long as it's at 60 and you have a regulator down past that, it can't ever get over 60, it'll just be less. And if you look over here, there is a gauge for every single solenoid and regulator for every device, because we highly want to tune what everything does. We'll show that in a little bit. Okay, again, keep everything organized, within reach, and visible. People have a tendency to try to pack it all in a corner and whatnot. That makes it very difficult for the inspector to figure out what's going on. And the more difficult it is for them, the more time they're going to be there, and that's less time you have to practice. Okay, pneumatic suppliers. There's Bimba, okay? They have the biggest variety of cylinders, okay? There's McMaster Carr. The advantage of McMaster Carr, they are a little bit more expensive, but you can get anything in 1 or 2 days, okay? If you order from Bimba, it's 2 to 3 weeks. So that's something big to think about. Automation Direct, okay? This is our favorite company, okay? They make everything. They make regulators, they make line, they make fittings, okay? You can get everything from them in about 3 days. There is a $30 voucher in your virtual kit of parts that you can get things from Automation Direct. One thing I want to tell you, it's a difficult voucher to use though. You have to put in your voucher code before you place your order, not at the end of your order, or it won't take. And then AndyMark. AndyMark is one of the big robot suppliers. Okay, they have a fairly comprehensive pneumatic line. They're a little bit more expensive, but if you're buying your other parts or your school's cutting a PO for robot parts, AndyMark's a convenient place to buy things. One advantage to AndyMark though is they do know everything about the game and what's going on with First Robotics, and so you can talk to somebody there to get help if you need it. Any questions there? A lot of times that people don't get what they need properly for pneumatics is because they don't know where to go to get the stuff. So this is very important, and look at this website later if you need it, this presentation. Okay? Bibliography, again, AndyMark, we got a lot of our parts and our documentation from there. The pneumatics manual, it changes a little bit every year, not a lot, but you need to read that thing cover to cover and follow it to the letter of the law. Vex Pro, that you can buy the pneumatic module through them, that's why it's on there. FRC Grasshoppers, they did a video. Anyway, FRC 358, they put something out there too in Norgren. Okay. All right, so we're going to show you on this pneumatic board how things actually work. So, okay, so I'm just going to enable it. Does everybody see? Or am I in the way? I'll come up here above and I'll let you run. Okay. All right, so it's going to come up to 120 psi and shut off. Eventually. And again, this is what you want to do before you go to the field. You want to do this in your queue with your robot enabled. Yes?
You have to use the battery.
Okay, this is an onboard system.
You have to use the battery that you're gonna compete with.
Okay, we always go to the field with 2 batteries. With the battery that was in the previous match still in the robot, we charge the air compressor, okay? We shut the robot off, we put our competition battery for that match in it, and then go to the field.
Is that legal?
Yes, that is completely legal.
Because they said that now you're bringing in a separate, energy source from a different battery.
Okay, but we haven't gone into the match yet. We're still in the queue, so we're just in line. And almost everybody's got an extra battery on their robot cart. What matters there is your extra source is when you're doing on the field, okay? Now, where they get touchy about that is if you are in the pit with an off-board compressor, you have to use the robot to control the compressor that is off-board, okay? I highly don't recommend doing this. We only did it 1 year, and it was terrible because your compressor can be off board, but you have to use the battery and the controller on the robot, hook to that, unhook that, and go out and not lose any air. And then the only air that you have is what is in the reservoirs. So if you use your device too many times, air pressure drops down, you're done. So, design your if you're gonna use pneumatics, design it with your compressor on the robot. One thing about it, you saw how long it ran? It just ran for probably, what, 20 seconds? All right, it's already warm. Okay, it builds a lot of heat. You see all the cooling vanes on here? Okay, you want to put this compressor on your robot somewhere where it can get airflow. If you bury it down in the bottom, this thing's gonna overheat. It builds a lot of heat. If you look on that robot right there, compressor's out in the open, okay? If you do decide to bury the compressor, because that's the only room for it, I would highly recommend using like a computer fan, power supply fan, or something like that. Because they will overheat, and as soon as they get hot, they lose efficiency. They take longer to run to go, and if you get them too hot, they burn up. Okay? All right, so now we're pressed up to 120 psi. Okay, so this is at 120. Okay, this is dropped down to 60. You want to point to where the low pressure? Okay, and he is now going to run the dual solenoid that will run this one up and down. Okay, so you see how slow it's going? All right. In pneumatics, you can control the power of a cylinder with your pressure. Okay, so at 60 psi, it has a lot of power. I can barely push it down. Okay, if we turn that regulator down, I won't have much pressure at all. I'll explain what this is in a second. All right, so go ahead and go down. Okay, so when I hold my hand and he pushes it, it's pushing pretty hard. Okay. All right, go down. Now take the regulator and turn down to 20 psi.
The high pressure one, or do you want the one that's actually going
The one that's going to this. Okay? Now push it again. All right, you got it more than that. What's going on here?
Yeah, for that one. You don't have a regulator on the bottom side.
Okay. Okay. Right. There we go. All right. All right, so now it's going to push it again. A little less pressure. Good drop. Off the needle. Okay, go back down. Yep. All right. Okay, see how, now give it a little bit more pressure with the regulator. Wrong way. You'll have to settle that again. There you go. All right, anyway, the idea is the higher the pressure, the more push, okay? But you can also control the speed without affecting the power, okay? So go down. Okay, this is a restrictor. So what this will do is this will slow down the airflow, but will not affect the pressure whatsoever. So if I turn this, and all it is a needle valve, and it'll slow it down, I can make this go extremely slow. Okay? Have it down. Okay? All right. Have it down. Get back. Okay? So that is how you control the speed of something. Okay, go again. There we go. All right, now go back down. Okay. Does everybody kind of understand that? Okay, so you can control the power with the regulator and the pressure, control the speed with the restrictor. Okay? They're simple to add in line, however you want to do it. There's a lot of times that pneumatic can be very, very violent. If the pressures clear up.
You got a question?
How much volume can you hold?
As much as you want.
There's no limit to how much stored area you have?
Nope, this is one reservoir here, that robot has 2. In 2015, we had 9.
And those Valeras, they're 100% duty cycle?
No, they are not, they're about 12% duty cycle. However, that's based on an hour, okay? That's 12 minutes on an hour, and we're only running for 2.5 minutes. So, we ran that compressor all season, and we worked it hard, and we've done 4 events with it, not a problem. The big thing is, don't let them overheat. Yes,
What was that called again that you were working on?
excuse me?
What was that called again that you were working on?
This?
Yeah.
A restrictor. And we have some examples of them here. Okay? Any other questions?
So when you said you had 9 tanks?
Yes.
When the compressor kicked in, how long did that take to fill up?
It would probably take about 2 minutes in the pits.
So, okay, but what about during the competition?
That is why we had 9, so we had enough volume
To
during
get
it.
halfway through?
So there's no way that the compressor could keep up.
Right.
That is correct. And we ran a set of cylinders up and down. It was the year that it was called Recycle Rush, and you had to stack totes. So in the process, we were stacking probably 25 totes. There was 25 motions up and down with cylinders that were about 18 inches long. It took a lot of volume, and a lot of teams had a lot of cylinders that year. Okay? All right, go ahead and yeah, so just go ahead and tell them, show them everything it does pneumatically.
One aspect of the game, probably one of those things you point out that the motor needs to make sure that there's not stuff in motion.
Oh, okay, yeah.
I think the Python's because I was working on crash well, okay, I forced shut it down. But
So pneumatics on this, we have 2 macro modules, 11 solenoids or something like that, cylinders. So, I mean, some of the actions you'll see, there's either 2 states on or off, like you explained before. Open, close, very easy. This one we have the power tuned down a little bit. If you saw before, if we go up.
Do you have a question? I feel like a 3,000 pressure tank, but you restrict it to like 100 psi. Could you still do that?
Say that now?
You can't use that, Dennis.
PSI.
Can't use like a CO2.
No, you're not allowed to. All the pressure has to be built by the air compressor.
Was that the air cylinder lifting it up as well?
That was a linear actuator.
Yeah, that's an action.
So you can see it has many positions. You can't do that with an air cylinder.
Right.
Yeah, so this is a linear actuator. Extending our arm, just again another cylinder right here on the back. 2 positions, out or in. So if we go back down here, that comes back in. Another thing, climber, so if we hit that, extends the hook up, it gets hooked onto a bar, comes back down again. 2 positions. You can see that the speed on this is a lot slower than the speed on this. We don't want our hook flying off. If we look underneath the robot here, and some of you might have to stand up to see this,
Or you can come down
or you
later.
can come down. You'll see on the bottom of the robot here that we have articulating wheels, so if you click it, these wheels go up and down. Change our drive mode on it. Again, 2 positions, 60 psi on that. We can tune this. Yeah. Also, these gearboxes right here are 2 speeds or little cylinders about this big. So if he goes forward, you can then shift to a different speed. You can hear the cylinders firing on that.
Okay, one thing that when I said the pneumatics are quick, okay, there's 2 ways to shift these gearboxes. One with electrical turbo, sorry. And they're slow, okay? So it takes about a second and a half to switch from from low to high, okay? Pneumatics is just like that. Just shift back and forth as fast as you can. Okay? That's the advantage of pneumatics. You can make it that fast. And that's how quickly the solenoids can react. So 4 of the cylinders that are on here, there's a little pancake cylinder on every one of the gearboxes. There's 4 gearboxes. Any other questions? We're kind of wrapping up. So if you guys want to come down and look at this, you're more than welcome to. Otherwise,